Today, we are here and we are going to look at the setup for this next lab. You'll be using a couple of pieces of equipment. We have the TI-84 calculators that we're going to use, and we have the CBR2. This is a motion detector. It's a sonic detector. It works a lot like a bat is able to fly. It sends out sound waves and it bounces it back, and it allows you to determine how far away you are from the detector. So these are the two things that you're going to need. You are also going to need this cord that has one of these plugs on each end, and I'm going to show you where they connect. On the detector here, it goes in the I/O port, and up here it actually connects to the top into this one. So those are the things that you need. Now when you pick up a cord from me, you will have a rubber band wrapped around it. It'll be nice and neat. When you return it to me, you are going to return it with that rubber band wrapped around it nice and neat, so I don't have a whole tangle of 15 cords floating around. So in your lab, or in your packet, you have the lab sheet here. Yours is white, mine is green, same type of thing. And there have been some changes that have taken place since we are now working with the TI-84 calculators instead of the 83, which is what this was based upon. So I just want to take and go through and make sure that you know what's going on and how to set this up. Okay. Another thing, if you read through here, we have the equipment and connect them with the cord. The cord is plugged into the top part of the calculator and into the I/O spot on the detector. Make sure they're plugged in tightly. It will check to make sure it has a good connection. If you take and you go to wherever you're working on this, you're going to need a clear shot for about 5 meters. You're going to mark off every meter on the floor with tape. Please don't use markers. Okay, we tried that last year and they grabbed whiteboard markers and left big marks on my floor that we couldn't get off, and the custodian was very upset with me. So you're going to find your spot and then start a ½ meter out from there, a ½ meter out, put a piece of tape and mark that as 0. Measure another meter, put a piece of tape, call that 1. Measure another meter, call that 2, 3, and if you want to go ½ meter marks just to stick those in there so you kind of know for a point of reference, that's fine too. You're going to go all the way out to the 5 meter mark. On and hit the apps button, which is right where my cursor of course is. It's this purple button. It says APPS. Just going to hit that. This will come up. You're going to go down to number 6. So that is a change. It is not number 4 on this calculator. It is actually number 6. You hit number 6 and it takes you to this. It says hit any key. You press any key, and then we want you to go down to number 3. Press enter, and then you are going to go to applications, which is number 3. You are going to select meters, and then we're going to start with the distance match. Okay, so number 1. Try to match the graph on the next screen. Study the graph, then press enter to start. So if you press enter, it gives you the graph. Now what you're going to do is you are going to take, one person is going to walk this while the other one watches the calculator to see what's happening, and you're going to start about what, 1, 2, maybe 3 meters, and you'll have to kind of play around and see if that's 3, and then you're going to walk over here. Okay, ooh, are you actually going to walk? You need to decide if you're going to walk or if you're just going to pause, and then you're going to take and you're going to complete this portion. When you are done, or when you're ready, you hit enter. You go ahead and walk. You'll hear your detector start clicking, and you see the light up, and that means it is reading your measurements. If you look here, you can see as I was just moving it around, this is what it was reading here. Okay, your goal is to get it right on this line. Sometimes you're a little above, a little below, but to have the basic shape of this. Okay, now you are going to do this, and once you have a graph that you're satisfied with, I want you to show me, and I will initial your sheet. Each person needs to do a distance match graph, and they can't be the same ones. Okay, so they need to be different ones. And I would actually like you to make sure that you get one really good one. So each person needs one really good distance match. Right? And then I will initial it. You hit enter again and it takes you back to here. Now if you didn't do so hot and you want to try that same one again, you can do a same match, or you can go down to do a new match. Let's say that was great. You had me initial it. Go on and do a new match. It'll give you a different graph and you can go ahead and do this. Now the goal is when you are done with this, I want you to be really comfortable with the shape of a distance time graph. I want you to know if we have a positive slope or an upward slope, what does that mean? If we have no slope, what does that mean? If it's steep and a negative slope, what does that mean? You need to figure this out, okay? Not only are you just matching the graph, but I want you to play around with this and see if you walk fast, walk slow, walk towards, walk away, what does it look like? So you know when you're actually doing this. This is supposed to help your understanding. Okay? Then there are some questions if you flip to the next page in this lab. And then here's some questions. How can you tell from a distance time graph that your motion is steady? And you're going to answer that question. If you flip over to the next page, it says, how can you tell from a distance time graph that the moving object has changed direction? And number 3, is it possible to move your body to make a vertical line? Why or why not? All right. So those are questions that you're going to answer about this activity, and you don't have a lot of room here, so why don't you just do it on a separate sheet of paper. If you want to type the answers in, just label it DT match, and you can then put the next part in there. Okay, we don't have the parts, we're not going to do the velocity time plots, but next what I do want you to do is I want you to go back to your calculator here. We're going to quit. We're going to go back to our applications, do everything all over again, except this time, instead of doing the DT match, I would like you to do the velocity match. This one's going to be a little bit different. Again, you're going to try to match the graph on the next screen, study the graph, then press enter to start. It'll give you a graph that looks something like that. I want you to try to duplicate this. Again, this one is more complicated to duplicate. We don't get real great data with the velocity time. But again, I want you to plot this, get your best one, show me, have me initial your paper, and then you can go ahead. And I want you to answer the same questions, so numbers 1, 2, and 3. But instead of this being a distance time graph, I want you to substitute the words in a velocity time graph. So again, you're looking to see how can you tell from a velocity time graph that your motion is steady. How can you tell that the moving object has changed directions, and is it possible to move your body to make a vertical line on a velocity time graph? Okay, so same thing, you can put that on that same form, either write it, jot it down on a piece of paper, or answer that in a computer file and send it to me. You can just email it to me. Okay, or share it with me in Google Docs. Either one is fine. All right.